In this lecture, we'll talk about what a sketch is. A sketch is basically another name for an Arduino program. We'll start looking at the structure of the sketch, but actually in this particular lecture, before we get to that, I want to define the language subset being used in Arduino. So really, an Arduino program is a C++ program, and we talk about classes in C++. Now, we're not covering classes in this course, but we need a little bit, just a little bit, so you understand how to use them in the context of Arduino sketches. So we'll do that. So an Arduino program, it's called a sketch. That's the term you see. C++ program. So Arduino is really the language that you're writing a sketch in is really C++. Using Arduino library functions. So there are a lot of predefined library functions, and you invoke those, but really it's C++ code that you are writing. Now, I would say that C++ is a superset of C. So there is C and there is C++. Anything that is legal C is also legal C++. So C++ has more features than C. And generally, when you look at Arduino sketches, the code that they're using, that people use, they restrict themselves primarily to the features of C. They don't go outside and use too many features in C++. Now, you could, but generally that's not what I see. But they do use some aspect of classes because they're used with libraries, and we'll get to that. So we have to know a little bit about what a class is, just because you're forced to use them a little bit inside your sketches. You don't have to define a class, but you have to be able to use pre-existing classes. So C++ includes classes, so let's just talk a little bit about what a class is. So a class is something that's used in the context of what's called object-oriented programming. So object-oriented programming, the idea is just a way to organize your code, really. That's all it's for, as far as I can tell. It's for organizing your code to make it easier to understand, which, by the way, is very important in big pieces of code, because code can get very difficult to understand. So object-oriented is a way to organize the data and the functions to make it more easy to understand. You're using what's called encapsulation. So you're grouping things together, encapsulating them into these units. So you group together data and functions that are related. So if you see a bunch of information, by data I mean variables, say, arrays, things like that. You have a bunch of data and a bunch of functions that act on that data, that operate on that data, and they are related in some conceptual way. Then you group them together into a single class. This is a common way to do it. So a class you can think of as a type that can be defined by the programmer, a user-defined type or programmer-defined type. So think of a type like integers, right? And every integer has the class of integers. We'll call it the class of integers. That type, it has data, which is the number, the actual integer. So the integer 3, it has the value 3, right? So that's its data. But in addition, the class of integers also has a set of functions, right? Plus, minus, times, divide, different operations that you can perform on integers. So every class you can see as having data, whatever the data is, and a set of functions associated with it. And types, like an integer, is sort of a very simple class. It's got just one type, one data, and it's got a bunch of functions that apply to integers. So those types that we have are predefined, right? Integers, floats, right? Float has a bunch of functions that are performed, a bunch of information data associated with it too. Those are all predefined. They're built into the language. But classes allow you to define new types based on your whatever type of program you're defining. So the application, you can make application-specific types. So you can think of classes like that. So let's just do an example. So here's an example of the use of classes and how it helps you to organize your code a little bit. So we got two examples of code that do exactly the same thing, the top and the bottom. Top example, we don't use classes. We say, look, we want to write some code that plots some points on the screen. Points with 2 dimensions, x and y dimensions. So one way to do it, I say I want to plot 3 points. So I define, I say int at the top line, and I declare a bunch of variables, x1, x2, x3, y1, y2, y3. And these are the x and y coordinates of 3 different points. And you can tell the x1 is related to the y1 because they both have a 1 after them. You as a programmer have to keep that in your head. x1 is related to y1 because of that 1 after them. x2 is related to y2 because of the 2 after them, right? So that's an extra burden on me as a programmer. I have to do appropriate naming so I can realize, oh, this variable is related to this variable. x2 is related to the y2, right? And this is what you're trying to get away from with classes, right? We don't want to have to rely on the coder The programmer doesn't have to, just if the programmer does some bad variable naming, it would be very hard to be able to tell which x and which y were related, right? But it's a burden of the programmer to name things in such a way that she can understand which variables are related to what. Okay, so I define these variables. Then the next line, I initialize them to zeros or whatever I want to initialize them to. And then I call this function plot, and it takes x and y. It takes the x and y coordinates that I want to plot. Okay, so I would call plot x1, y1, then call plot x2, y2, and so on. So that's one way that you could represent these 3 points and plot them. Now below, what we're doing is we're showing how you might do this if you have a class. If you have already defined a class called point, then you could do it in the way shown below. So this class called point, every point would have to have an x and a y coordinate inside it. So in our class definition, which I'm not showing you right here, it would define an int x and an int y. So now when I declare my variables, I don't declare the ints, I declare the points. I say point, p1, p2, p3. So that declares 3 different points. And I don't have to explicitly declare the x and the y for each one of these points. I can just say point p1, p2, p3, and because I have defined this class of points, the machine will know, okay, p1 has got to have an x and y, p2 has its own x, y, p3 has its own. Right? So those get defined without me having to think about the details. Right? I just say make a point, and the program says, oh, a point means there's an x and a y. So I declare my points, then I make a new point. So there I say p1 equals new point 0, 0. New is a function that creates a new object of any particular class. So that actually initializes the p1 and the p2 and p3. You'd make a new point, and 0, 0, the arguments, those will become the x and the y values for this point. So I initialize that, and then I call a function called p1.plot in order to plot the point. Now notice how that plot is different than the plot above, right? The plot above takes 2 arguments, x1 and y1, which is the coordinates that I want to plot. The bottom plot says it doesn't have any arguments, right? It's just p1.plot. So the reason why it doesn't need the arguments is because it's called from p1. So p1 is the object that we've created, the point. And if you say p1.plot, it basically tells the plot function, look, when you're looking for variables like x and y, refer to what is on the left-hand side of the dot. Right? The left-hand side of the dot is p1. So it will use the x and the y values from p1 and plot the point accordingly. Okay? So, and actually that notation right there, we're going to be using that, where we say, we give the name of an object or a class, then you give a dot, then you give the name of a function. We're going to be using that throughout. That's how Arduino sketches are, that's how library functions are often invoked, is with that type of syntax. So we'll look at that more later when we get to some sketch examples. But this is generally what a class is useful for. So yeah, all data is contained in one object. So all the data related to a point, the x and the y in this case, are contained in this one object, this point object. So p1 has its x and y, p2 has its x and y, p3 has its x and y. There are fewer parameters. So because we have fewer variables, right, we don't have to have x1, y1, x2, y2, x3, y3. We just have p1, p2, p3. So we've reduced the number of variables that we have to use and reduced the number of arguments to functions. So our plot function takes no arguments now, right? It doesn't have to take x1 and y1 explicitly. You just say p1.plot, and it knows where to get the data from. And you can define point-specific, when I say point-specific, class-specific functions. So in this case, point-specific. So the function point, or plot, is specific to the point class, right? You can only call plot, in this example, on something in the point class, so p1.plot. You can't call, say you have an integer, right, x. You can't say x.plot, because plot doesn't work for an x. There's no plot function defined for an integer. Right? But p1.plot, since p1 is the point, and we've defined plot for points, then that will work. So you can make these class-specific functions. Thank you.